Let's do problem 36 valid Sudoku. So in this question, we have to check if the Sudoku board is valid. To do that, we have to check for three things. One is row only contains the numbers 1 to 9 without repetition, same for columns, and then same for this 3 by 3 grid. So the board is represented by character array of an array, and we have to we have to check for these three conditions for each element we see. So we are going to use two for loops, just a standard one, which is for int I is 0, I is less than 9, and I plus plus, and then same for j. Okay, so this way we're going to look at row by row, and then by the end of our iteration or before, we will have figured out if the Sudoku board is valid. So, and one thing is, if the value is empty, we don't really need to do anything. So if the value is empty, we can just do continue. All right, so let's start with something easy. So let's start with row. Row is pretty straightforward because I represents row number, j represents column number. So for to track if the numbers have appeared, we do need a variable called rows 9 by 9, and this row basically keeps track of the numbers that appeared in this row. Okay, and if the number has appeared, we just have to update it. So this red line red numbers represent indices, but the blue numbers represent the actual numbers. So for our first iteration, if we do board I and j, it's going to give us 5, but we want to update our fourth index because it's 1 less. So we have to do 1 minus 1. So I'm going to call it position, int position. So we are going to do if this rows I and position is 1. For example, everything will be empty initially, but if it's 1, that means the number has appeared in that row. So in that case, we just do return false. Otherwise, we do rows I and position to 1. Okay, simple. So if the number is 5, we just update that to 1. And then when 3 appears, we update that to 1 as well. Okay, simple. And the same thing will be applied for columns. So we're going to have if calls j and position is equal to 1. In that case, return false. So you might be wondering, why do we have I and then why isn't j here? Well, because this column basically represents this row, and then this row basically represents this row. So that's why we have j here. So they will be applied sequentially but within one iteration. So if we put 5 here, we will have put 5 here, 1 here as well. And then when this 3 is applied here, we will, because it's the first column, we will apply, what is it? It's, where is it? So that's the first row, so 3 will be applied here like this. Okay, so that part is straightforward. But the real question is, how can we identify each grid? And also, what are we going to call them? Well, we can just simply call them 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay? And within this loop, obviously, I mean, before the loop, we do need some variable like rows and columns, but because it's a square grid, I'm going to call it square 9 by 9. And And how can we identify the column, identify each of the grid? So it will be 0, 1, 2. Well, because it's within a for loop, we have to use I, and then we have to use j, and then because it's a 3 by 3, we have to use the number 3. So what happens if you do I divided by 3 plus j divided by 3? Well, if we do that, in this row, I divided by 3 will give us 0, and then j divided by 3 will also give 0, so we are going to get 0 here. But in the next one, we are going to have 1, and then the next one, we are going to have 2. Okay, so this equation works for the first row, but what happens if we go to the next row? So if we apply this logic as well, the next row we are looking for this grid, we are looking for 3. But if we apply the logic, we have 1 plus 0. But we're looking for 3. So we can just simply multiply this one by 3. Let's see if it works. So when we come here, we have 4, and then we also have 5. Okay, so this equation works. So we're within, after this rows and columns, we're gonna have, say, I don't know how to call it, we can just call it index or something, or a square number. Okay, let's do a square number, and then assign a square number to this logic, and then again do the same thing. If square, instead of j we can put square number, and then we can just do square number, and then we can put position in. And that's pretty much it. Well, when it comes to the 3 by 3, my explanation was pretty awful, but hopefully I can understand. So let's do int 9 by 9. And then calls 9 by 9, and then we have squares 9 by 9. Oh yeah, also one thing I forgot to mention is, again, for squares we're gonna have like this sort of array arrangement, and then each row represent as each square. Okay, and then we do need a for loop. Int I equals 0, I is less than 9, and then I plus plus. For int j equals 0, j is less than 9, and then j plus plus. Okay, and then we're gonna get if empty, we return continue. No, we just continue. So if board is empty, what is empty? It's just dot. We continue. Okay, and then we have to use we have to get position variable, so it will be board I and j. Because it's character, we can't just do that, we have to do this, and then it's automatically going to typecast it to integer. And we're gonna check for rows. So if rows I and position is equal to 1, we return false, else rows I and position is equal to 1. Okay, and then same thing will be applied for columns. So if calls, so instead of I, it's going to be j, and then it's going to be calls and then j. Good, and then we do need the square number. Int square number is equal to 3 multiplied by I divided by 3 plus j divided by 3. And then we're gonna do the same thing. So instead of rows, we're gonna put squares, and then instead of I, we're gonna put square number. and then it will be squares, and then square number. Good. So that's it. And then if the false statement hasn't been procced in for loop, that means the Sudoku board is valid. So we can simply return true. So there's a slight pattern. I represent the row number, and then J represent the column number, square number represent the square number. So it's kind of repetitive. It's the most difficult part was coming up with this equation, I think. All right, so let's run the test and see if it works. Okay, so we did not get the correct value, so I'm assuming my as okay, so I should put I instead of 1. Okay, let's run the test again. All right, so what's going on here? Well, let's see. Calls, squares, return false, position. Okay, it's an interesting one. I'm assuming if I put it this way, this, it might work. Okay, let's run the test again. Okay, so there was something wrong with my mathematical equation, but let's submit. Okay, and then the result is good. Right, so that's it.